So this is tutorial number 5. A converging elbow turns water through an angle of 135 degree in a vertical plane. The flow cross-section diameter is 400 mm at the elbow inlet and 200 mm at the elbow outlet, section 2. The elbow flow passage volume is 0.2 meter cube between section 1 and section 2. The water volume flow rate is 0.4 meter cube per second. So this is the volume flow rate, Q. And the elbow inlet and outlet pressure is 150 kilopascal and 90 kilopascal. The elbow mass is 12 kilogram. Calculate the horizontal and vertical anchoring forces required to hold the elbow in place. So in this situation, they give you complete data to start your calculation. I think you could easily understand that we have inlet and outlet pressure, section 1 and section 2 pressure. So and then it gives you the diameter at inlet and outlet here. So and then they give you the flow rate Q. So means by all those data, you could calculate the velocity for section 1 and section 2 and also the pressure for section 1 and section 2. Okay, so and then they give you new things, which is the elbow mass. So the elbow mass is 12 kilogram, means that the elbow itself causes weight. So and then they give you that the elbow flow passage volume is 0.2 meter cube. So we will discuss about that. Okay, the idea is fluid will flow all the time in this section. So means because fluid has mass and it will interact with gravity, so it will create weight downward like this one. So mean weight that come from the fluid itself. So another one is the elbow. This elbow is made from metal. So again, metal will give us weight, and the weight is act downward like this due to the acceleration of gravity. So means that in y direction we have an extra two external forces. One is weight from the water itself, okay, and then the second one is the weight from the elbow. So this is two external forces that we need to add on in our calculation in y direction, not in x direction, only in y direction, because these forces comes from the acceleration of gravity. So this is the control volume. So and then we assume that this is the direction of Rx and Ry. So and then we could have a diagram like this one. So we have a pressure at outlet here, and then we distribute into x and y component. Okay, also the velocity, so we also divide them into x and y components. So and then we could calculate the velocity according to the flow rate that we get. So for section 1 it is 3.18 meter per second, and section 2 is 12.73 meter per second. So and then we could develop our momentum equation. So this is the equation. So and then we could substitute all the values. So we could get the Rx is negative 26 kilonewton. So means that we need to change the direction. Now the Rx is actually need to be installed on that situation from right to the left, and the magnitude means the amount of the force in y direction need to be installed is 26.55 kilonewton. So and then for y direction, so you just do the same, but you need very careful. In y direction you need to add the weight of the pipe, means the mass of pipe times the gravity, and also the weight of the water. So the direction is negative because we assume that upward is a positive direction and gravity will pull it downward, so it will give us negative value of forces. So you calculate everything, so you will get the Ry is negative 3500 Newton. So previously we assumed that Ry is work upward, but we get negative answer, so we change the direction. So the Ry will act downward with a magnitude of 3590 Newton. So this is the final answer that you should get for these problems.